a special case under series where we'll be following for geometric progression only. The special case is here about infinite geometric series. So the heading itself will be infinite geometric series. Okay. So far, we were discussing two formulas on the series for geometric progression. One is a into 1 minus r power n divided by 1 minus r, where r is less than 1 or greater than 1. And another one formula a into r power n minus 1 divided by 1 minus r, r minus 1, where r is greater than 1. Okay. In addition to that, we'll go for one more formula where r happens to be lying between these values. See, minus 1 to 1. For convenience sake, let me take this in the number line. Okay. So here is 0. After this, we'll get all positive values. No doubt in that. Before this, we'll get all negative values. Here will be 1, 2 and so on. And here will be minus 1, minus 2 and so on. Okay. First two formulas is meant for what? Finite only. Okay. You need not check where it lies. If it is blindly r less than 1, you use the first formula. R greater than 1, you use the second formula. Where in the case of finite series. This third formula we are going to discuss in the case of infinite series. What do you mean by infinite series? Means where you will have a very large n where the definiteness is not known. Definiteness with respect to the end is not known. So probably this infinite series we are going to discuss in this category only. Okay, I want to place a star mark. I'll give you time later. You can make a note of it later. You just listen here. When we say n is large, you cannot give a number for a large. Probably we can tell me, ma'am, 1000 is a large number, ma'am. So far we were discussing 10 numbers. There is 10 numbers in a progression, 15 numbers. You can say n is equal to 1000 is a large number. No, you cannot say. Okay. Because if you say that's the last term, it becomes finite. Because the definiteness is known. If you take n is equal to 1 lakh number of terms is present, definitely this is also not infinite. This is also not large because it's known. What do you mean by large is something not known is what you call as large. Okay. In mathematics, instead of saying n as large, we say or we use the mathematical notation as n tends to infinity. Okay. How you read this? Let me go with the descriptive manner. N tends to infinity. What do you mean by infinity? Very large number. Tends to means is actually not equal to infinity. There is no such concept called as infinity. It goes on and on and on, goes on near to closer to infinity, but it's not infinity, which means it's very large and large and large. We cannot say how large it is. Okay. So this is how you pronounce this or you spell this one as n tends to infinity. Okay. So far we were using the formula S is equal to A into 1 minus R power n divided by 1 minus R. Okay. Let us focus or zoom on this R first. What is this R? This is a ratio. Okay. I hope you are strong with calculations. Can you get this? Can you get me this value 1 by 10? Yes, please. Appa, don't use calculators and all. 0.1. Okay. 1 by 100. Okay. Just don't tell me the values. Analyze what is happening inside. Yes, 1 by 1000. Okay. 1 by 10,000. Okay. 001. Sorry. So it goes on. What you find from this? This number, denominator, increases, increases, increases. Okay. This number, what happens? Decreases. When the denominator increases, the overall number will decrease. So, for this r, what I'm going to do is, I'm going to take 1 by r, where this r happens to be a very big number. Okay, when r happens to be a very big number, then this r will be closer to 0. You agree with me? This r is 10. What will be this R value? 0.1. I'm saying this R is very big. How big it is? 1 by 100. Ma'am, this is not very big, ma'am. This is somewhat bigger than 10. It's 10 square, right? Guess what happens here? 0.01. Okay. I say this R is 1 by 10 power 100. 10 power 100. Can you guess this value? Okay, you're taking the help of the calculator. Tell me. So if you have taken the help of the calculator, can you share the value? 1000. 1 by 10 power 100. So you'll get somewhere 0.00000. Definitely you'll get one. Somewhere one. So this happens to be a very, very, very small number. Small is such a way that this happens to be somewhat equal to 0 itself. Please try to get my point. When this happens to be a very, 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 very big number, then this overall R will become a very, 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 very small number. Smaller is such a way smaller that is closer to 0. If you round off to 2 decimal places, you say 0. If you round off to 4 decimal places, you say 0. If you round off to 100 decimal places, you say 0 only. Because after that only 1 comes. Somewhere it comes. So far what we have done here is, see, I said n is large. Large means what? So very large, it can be any number closer to infinity. So this is one condition. Second condition, I am taking R is equal to 1 by capital R. See, this is small r, this is capital R. So capital R is meant for very large. Okay. And third one, 1 by R power n, which is nothing but small r power n, tends to 0. You agree? See what we have taken? R is equal to 1 by R. Okay. So for convenience sake, I took 1 by 10 first. Then I took 1 by 10 power 100. So this n value, 100. This need not be 100. It can be any value. I took it as 100. This itself gave some value 0.0000, some value 1. Somewhere 1. So this happens to be 0. So 1 by R power n, which is R power n, will be somewhat closer to 0. So R power n tends to 0. Under these three conditions, now my formula S will be, actually what I took the formula was this one. Okay. Now tell me, let A be as it is A. A, what is as usual 1 only. What is R power n? Tends to 0 means it's equal to 0. So I can take it as 0 itself. Divided by 1 minus R is R itself. What happens here? A divided by 1 minus R. So this is your series for infinite geometric series. This is your formula. So what's the third formula here? What's the third formula here? A divided by 1 minus R. There's one more condition. Minus 1 less than R less than 1. Which means you're focusing on this area. C is not equal to. If it is equal to means R equal to 1 and R is equal to minus 1. Right? I cannot take that value. Because R should be smaller. Only if R is smaller, I can talk about 1 by R power n, which will be small. Okay. So three conditions. One condition is this one. Second condition, because it's about infinite series, you will be getting n tends to infinity. Third condition, I'm taking R is equal to 1 by R. So obviously R power n will be 1 by R power n, which will be tending to 0. Yes, please make a note of it. What happens when R is equal to 0? For example, let me take A value as 5. Can you frame the geometric progression? 5, 0, 0, 0. Okay. So when R is equal to 0, the progression will have only one element. Actually, there are so many elements following with 0, but the first element only will be 5. Others are all 0. What would be S? Hmm? What would be S? What is S? By definition, sum of the terms. Yes, what is the value of S here? A itself. So you can extend this formula. When R is equal to 0, what is S? See, you add, right? 5 plus 0 plus 0. Last term also will be 0 only. So you get 5 only. A. Okay. Another one particular case, R is equal to 1, A is equal to 5. Yes, can you please help me out? What would be the progression? 5 comma 5 comma 5 comma. Yeah, please tell me. What would be the sum? The series. Probably let me have it has 100 terms. What would be answer? Series. Series means you have to add all. 5 plus 5 plus 5 plus 5. How many times? 100 times. Yeah. 100 into 5. 500 will be answer. Which is n into a. Am I right? So when r is equal to 1, your s will be na. So you can find any number of formulas. Yes, can please make a note of it. Will I take over? You go for a problem. Your question is, so you need to copy anything. Done. So the question here is, you evaluate, okay, evaluate 0.2175 bar using the sum of infinite geometric series. Okay, using the sum of infinite geometric series. First, try to understand why it is given infinite geometric series. If you have a look on this number, it is 0.2175 bar. What this bar represents is 0.21757575 will be repeated. You will not know the stop, which means you will not know the end, which means obviously it happens to be an infinite term. Okay. For example, if you take 0.1 bar, what would be the value? 0.111111. You take 0.759 bar. This will be 0.759999. Okay. So this 0.2175 bar is nothing but 0.21757575 so on. It will come in pair only 757575. Please check whether shall I write 21 as 20 plus 1. No doubt. Shall I write 2.1 as 2 plus 0.1? So shall I write this one as 0.21 plus 0.00757575? Yes. Please check whether shall I write the second term as 0.0075, okay, plus 0.000000757575. Yes. See, this place I'm replacing. This one I'm splitting here. So the next term will be containing all these values present first for 0 other terms as usual. This will go on, right? What will be the next term? Can guess what will be the next term? 0 point. How many terms I'll get 0? 1, 2, 3, 4 already present. And for the 7, 5, I take 7, 5. Then 0.000000, then 7, 5, 7, 5. So this will go on path. That's why it's called as infinite geometric series. Okay. So first one, I keep it as it is 0.21. So hereafter, I'm going to have 7575 repeated. Actually, check whether I can write this way into 10 power 4 divided by 10 power 4. What is into 10 power 4? What happens? Talk about only up to the numerator. What happens if I multiply 10 power 4? The decimal will be shifted to the right hand side. So this will become 0, 0, 0, 7, 5. Why? 1 place, 2 place, 3 place, 4 place because power 4. Now I divide by 10 power 4. It will be shifted to the left hand side. My decimal is over here. 1 place, 2 place, 3 place, 4 place. So it becomes 0.0075. See, the number is not changed. This is the beauty of maths, right? When you multiply and divide by the same number, the number will not get changed. So I'm getting the same number. So here I multiply and divide by 10 power 4 throughout so that I'll get this as 1 by 10 power 4 into 75 plus 0.0075 plus 0.000075 and so on. We can find a difference here. See what happens. I'll make a tick mark. Please check this one and this one. What happens here? Because I have divided by 10 power 4 and multiplied by 10 power 4, it is being shifted. Decimal is shifted. And here, I have multiplied and divided by 10 power 4. See, 1, 2, 3, 4. So it's, sorry, then I have to write 0.75, sorry. Yes, what happens? 0.75, right? Tell me. Plus 0.75. Then again, it shifted to 4 places. 1, 2, 3, 4. 7575 will go on. Then 0.7575 it will go on. Okay? Right? So now it happens 0.21 plus 1 by 10 power 4 will be same. What happens this progression alone? This is a geometric progression. Okay, what happens here? It is shifted. It is getting shifted. So this is 75 is a, okay, I'll write it here. A is 75, the first term. So first term. Okay. How you get the second term? See, the point is shifted over here. Okay, the point is shifted over here. So you'll get R to be 1 by 10 power 2 because you're shifting 2 decimals. 1 by 10 power 2. So you know the value of A, you know the value of R, and R happens to be less than 1. Okay, R happens to be less than 1. So what's the formula for S? A by 1 minus R. Why A by 1 minus R? It's an infinite geometric series. So I write here the S value. What is A? 7 divided by 1 minus R value is 1 by 10 square. Is it okay? Now next step 0.21 plus 1 by 10 power 4. I keep it as it is. 75. I take it outside. Okay. Now the left out will be 1 minus 1 by 100. 1 by 10 square. 1 by 100. Next step 0.21 as it is. 75 divided by 10 power 4 as it is. Now I take LCM. Numerator as it is. Denominator is 100 minus 1 divided by 100. You agree? I'm taking normal LCM. Next step 0.21 plus 75 divided by 10 power 4 as it is. I take this 100 to the numerator. So 100 divided by, what is 100 minus 1? 99. Okay. Next step 0.21 as it is. 75 divided by 10 power 4. Okay. This 100 can be written as 10 power 2 divided by 99. Okay. Next step, not it over. 0.21 plus this 10 power 2 and 10 power 4. If it gets cancelled, you will get 75 divided by 10 power 2 into 1 divided by 99. Okay. What we do here is we take 0.21 plus 75 divided by 100 is 3 by 4 into 1 by 99. Okay. So this is 0.21 plus what is the value? What's the value? I just don't want in decimal. Okay, give it in decimal. Let me find it in decimal. Uh, 3 divided by 396. Yeah, what's the value? 0.21 plus hmm, 0, 0. That's the very first step in our problem. You agree? See, this is what you will get. You got this one? Okay. See, 0.21 as it is, 0.00757575, you get the same one. But in our exam, what they do here is they are asking in fractions. So probably from here, you can also represent the problem as you take LCM. Okay. What is 0.21? Is 21 divided by 100. Okay. Okay. And what is this value? 3 divided by 396. So this step I'm here. This is 3 divided by 4 into 1 by 99. 3 divided by 396. Shall I write this as 21 divided by 100 plus 1 by 132? Normal division. Okay. So if I take LCM, please check I'm getting the value 359 divided by 1650. I have to take LCM. Okay. You need not take the LCM, you'll get this only. You just listen over here. And what is this value now? 359 divided by 1650. 0.21757575, you get the same value. So you get 75 bar. Again, you're not going to work out so many steps in the exam. Your answer will be this one, because this was asked most of the times in the exam. 359 divided by 1650. See, the beauty of this problem is you have to get this repetition. Can you please find this answer again in your calculator and tell me what value you're getting? You will be getting for some 8 or 10 places, right? Just type this number 359 divided by 1650 in your calculator and tell me what 0. Yeah, 21. How many times you're getting? 7575757575, right? Okay, after that, probably you're not getting, I think. Only this many numbers will be represented in the screen, right? Okay. So you have to get 757575. Okay, if this number is not 1650, 359 divided by, I'll take a meager difference, probably 1550. It's not a meager difference actually, it's 100 points difference. What's the answer you get? 0. 0.23. See, you're getting a difference. Or if I take 359 divided by 1600. 22. Okay. If I take 359 divided by 1625. 22. So at one point of time only you'll get 75, 75, 75 and 75. So I request you to make a note of this number 359 divided by 1650 because it's often repeated. All these steps are not necessary, so you need not copy also, it's there in the single material. You just make a note, all these things are happening. We are taking the help of this formula. What's the formula we are taking the help of here? S is equal to A by 1 minus R. You need to understand what is this A value, what is this R value. And why we are using this formula? Because it is infinite geometric series. Question here is, find the sum of the series to n terms. One question is given 3 plus 33 plus 333 and so on. Okay. The dot seems to have no end, but it's mentioned as to n terms, which means it's a finite geometric series. And second question is 0.7 plus 0.77 plus 0.777 so on. Seems like no end, but it's mentioned as two n terms. So again, this is also a normal geometric series, finite only. Okay. So we are going to find the sum. So I represent this as capital S. Throughout we find that 3 is common. So I take it out 3. What happens? Please help me out. We'll get 1 plus 11 plus 111 and so on. Okay. Up to n terms. Okay. Up to n terms. And here is equal to 7 is common. So if I take 7, this becomes 0.1 plus 0.11 plus 0.111 and so on. Definitely there is an end up to n terms. Okay. Hereafter, we'll make some small alterations. There is no such hard and fast rule, but to have a small convenience, step by step convenience, we're going to apply here. So let me place a star mark. This 3 seems to be common only, so I'll have 3 outside. Instead of having 1, I'll take, I'll multiply and divide by 9. Okay, I'll tell you why. Okay, probably after 3 or 4 steps, you'll come to know. I'll multiply and divide by 9. So this star is multiply and divide by 9. Okay, so what will get? This become 9 plus 99 plus 999. Am I right? Up to n terms. You want to make a check. See, first one. What happens? 3 into 9 divide by 9. See, 9 and 9 get cancelled, you get 3. Correct? For example, if you go for this one, what you'll get? 3 into 999. Okay, divide by 9. Get cancelled. 111. So you get 3 threes. Okay. So this is how we proceed. So the same we do for the second problem also. Multiply and divide by 9. Yes, please join. What do you get? 7 divided by 9 into here will be 0.9 plus 0.99 plus 0.999 up to n terms. Okay. Again, we make a small simplification or alteration. Let me have 3 by 9 as it is. Instead of writing 9, I write it as 10 minus 1. Okay. Again, after 3 or 4 steps, I'll explain it to you why. So this is, I'll place second star mark. Okay, there is a small alteration. Instead of writing 9, I'm going to write 10 minus 1. So can you guess what would be this one? 10 square minus 1. 100 is 10 square. So 100 minus 1, 99. Can you guess the third one? Yes. Up to n terms. Yes, the second problem. 7 by 9. Here I cannot write 10 minus 1. Instead I can write 1 minus 1 by 10. What is 1 minus 1 by 10? Yes, please join. 1 minus 1 by 10. 1 minus 0.1 will get 0.9, right? Next term. Next one. 1 minus 1 by 10 square. Yes, what will you get? 1 minus 1 by 10 square is 1 minus 0.01. 100, right? 1 divided by 100, 0.01. So this will be 0.99. Okay. Yes, next one. 1 minus 1 by 10 power 3. So this will be as usual. Okay. Shall I continue? So first star, we are making a small change. We are multiplying and dividing by 9. Because we are multiplying and dividing by 9, the number is not changed. We are getting the same. And second star, so this is the first star. Second star, we are changing 9 to 10 minus 1. Here we are changing 0.9 to 1 minus 1 by 10. Now I'll do some small grouping work. This is 3 by 9. Okay. I'll group all the 10s together. Check. Am I writing right? Is it right? I'm grouping only the 10s. 10 plus 10 square plus 10 power 3. For how many terms? 10 terms. Sorry, n terms. And what is left out? Minus 1, minus 1, minus 1. How many times you'll have minus 1? N number of times. Because n, right? N number of times. So shall I write this as minus n? Why? 2 plus 2 plus 2. 3 into 2, right? Minus 2, minus 2, minus 2. How many times minus 2 comes? 3 times. So 3 into minus 2, right? Okay. 1 plus 1 plus 1 plus 1. 10 times. Yes, please join. 10. Okay. Minus 1, minus 1, minus 1, minus 1. How many times? 10 times. So what will you get? Minus 10. Okay. Here, instead of 10, we have what? N. N times we get minus 1. So what will be, what will the value will be? Minus n. Okay, the same thing happens over this side also. 7 by 9. Yeah. I'll group now. Here grouping will be started from 1, 1, 1 and so on. So shall I write this as n? How many ones will be present? N number of ones will be present. So n minus 1 by 10, 1 by 10 squared. So I open a bracket, 1 by 10 plus, why plus? Because I'm taking a common minus outside. So 1 by 10, 1 by 10 square, 1 by 10 cube. How many terms? N terms. Please check whether this step is okay. Is this okay? Right? Shall I continue? This is nothing but geometric progression, geometric series, right? And what is the value of A? Please join, please join. What is the value of R? 10 into 10 is 10 square. 10 square into 10 is 10 power 3. Value of R is 10. So what's the formula I'm going to use here? R is 10 means greater than 1. What's the formula use here? S is equal to A into R power n minus 1 divided by R minus 1. Come over here. This is about geometric progression. You agree? What's the value of A? The first term is A, 1 by 10. What is R? 1 by 10 multiplied by 1 by 10 is 1 by 10 square. Okay, so this is 1 by 10. 1 by 10 is obviously less than 1. So what's the formula for S you're going to use here? A into 1 minus R power n divided by 1 minus R. Now we apply the formula here. Tell me, this is equal to 3 by 9. Okay, apply the formula. S value for this one. 10. See, applying over here, okay? Now tell me. 10 into 10 power n minus 1 divided by 10 minus 1. I can write it as 9 itself minus n only because you don't know how many number of terms given. So it's n only. Okay. Now come over here. 7 by 9. Yeah. N is present. So I just keep it as it is minus. Now I apply the formula for this one. Okay. For this one. Yeah. What is A? 1 by 10 into 1 minus R is 1 by 10 power n divided by 1 minus 1 by 10. Let me keep it as 1 by 10. Then I'll simplify it. Now come over here. 3 by 9. Yes. 10 into 10 power n minus 1 minus, if I take LCM, this will be 9n. Okay. Shall I bring this 9 outside and make it as 81? So this will become 3 by 81 into 10 into 10 power n minus 1 minus 9n. Okay. Then come over here. 7 by 9. I keep n as it is. 1 by 10 I have. Okay. What happens here? Probably I'll zoom out in brackets. Yeah, tell me. What happens here? Actually, if I zoom out, this will be 1 minus 1 by 10 power n. Next step will be 10 power n will be taken LCM. So 10 power n minus 1. Okay, so this is 10 power n minus 1 divided by 10 power n. And I have 1 over here, which is 1 by 1 minus 1 by 10, which is 10 minus 1 by 10, which is 9 by 10. So let me have over here, divide by 9 by 10. Actually, 9 by 10 is 1 into 1 by 10, so I can cancel over here, right? Okay, so I'll have 9 alone. So if I don't want to skip this step, let me make it as a one more step. So this is equal to 7 by 9. Okay, n as it is minus 1 by 10 into 10 power n minus 1 divided by 10 power n divided by 9 into 1 by 10. Now I cancel it. Okay, fine. So next step, 7 by 9. Okay, actually you'll get LCM and you'll get 81 only. I take LCM, so this will become minus 10 power n minus 1 divided by 10 power n. Okay, and the whole divided by 9. Obviously, I'm not going to write 9 here. Instead, I'll write 9 here and make this as 7 by 80. Okay. So this is the case where R was 1 by 10, which is less than 1. And this is the case where R was 10, which is greater than 1. And if you make a check here, you will get n this side, which is 9n this side. And here you will get positive 9n as the first term. Okay. Obviously, you're not going to have all these steps in the exam, but unluckily, we have to uh, go for the in-between steps because your options will be given as in-between steps. Can you refer to the Singer material? Can you please join? So probably if you ask me, ma'am, why did you do this multiply and divide by 9, ma'am? Why you did this 9 as what? 10 minus 1? Because you use the formula. Okay. See, I have to use this formula S is equal to, right? So I need to know the value of A, I need to know the value of R, then only I can use the formula. So that's why we're doing all this. Now please join here. Whether it's 3, 33 or 4, double 4, triple 4, anyway, you're going to take this 3 and 7 outside, right? Right, please check here. This is quite important. So at the end, definitely you'll get the 3 and 7. So can you guess what would be the formula? 4, 44, triple 4. Your answer will start as 4 by 9 or you'll have 4 by 81. Am I right? So this is a guess. And this are all numbers greater than 1. So obviously your format will be looking like this, right? Actually, it's 10 into 10 power n minus 1. So we got this way. But when you go for this one, 0.7, 0.77, the R is going to be less than 1. So you'll have something like 10 power 1 by 10 power n. So this will be 10 power minus n and so on. So this is the hint you can take it. This is also often repeated question. You can please make a note of it. So one point I request you to make a note is I'll place a star mark. So this 3 will be carried on over throughout the term. And here you will find n, which is minus n, it looks like. And here you will get it as plus n. Okay. And the last one, you can, if you want, you can memorize this one. If you want, you can memorize. Okay. So these 3 steps are needed for. Instead of 3, if they have given us 444 means the final answer will be 4 divided by 81. Then you will not get 1 by 27. So obviously 3 by 81 is 1 by 27. That's why we have 1 by 27. If it is 4 divided by 81, the answer will be 4 divided by 81. Okay, so you can please make a note of it. Yes, please.